Hi, my name's Taylor Toby. I'm an OpenSciEd teacher and facilitator, and I'm here to discuss with you Lesson 11 from the 8.4 unit, Earth and Space. How did we get here? In the previous lesson, we figured out that when you shine light through a simulated atmosphere, it changes color and gets dimmer. The more atmosphere or particles the light travels through, the redder that it gets. Let's break down Lesson 11. It is an investigation lesson, takes 2 days with about 20 minutes of prep time. It is hands-on, but there are also videos and images for students to look at, so devices are required. There is an optional refraction of light video. I highly recommend it. On the first day of this lesson, students figure out that when light travels through different materials or different shapes of materials, the path of that light changes, and sometimes we can see different colors. After analyzing and thinking about those experiences, students figure out that when passing through certain materials, white light changes direction, and the different colors that make up white light travel in slightly different paths. By the end of this lesson, students will figure out that when light interacts with water or glass of certain shapes, we can get a rainbow, or at least parts of the colors of the rainbow. And each of those colors are less bright than the original white light. And after the white light changes its path and splits into those different colors still continue to travel in a straight line. And we also figure out this process works in reverse. You can combine different colors and get a resulting white light that is brighter than the individual colors of light. Where we're not going in this lesson is having specific conversations about quantitative data. We're not measuring the angle of reflection or refraction, and we're not talking about specific wavelengths. We're only talking anecdotally and with qualitative information, such as red refracts the least and blue or violet refracts the most. And so you can predict the order of the colors that you'll see when a rainbow is produced. Let's look at some key moments in Lesson 11. Part 5, Conducting the Rainbow Lab, is a really important piece of Day 1. Please remind students to move the light or the object after they take their initial observations. They want to find ways in which they can make the rainbow either bigger or brighter, or if they didn't see one to begin with, to get a rainbow to appear at all. If you have students struggling, so listen in on their observations, encourage them or question them about the path of light. Where is it going when it leaves the flashlight? What happens when it reaches the object? What happens when it leaves the object? Ask questions about color changes and if they notice any different colors, or you could ask them about the brightness of light. The more observations and the more specific their observations are, the easier it'll be to model later on. And then part 7, developing that model, is a big piece of Day 2. Really encourage students to pick a lab station that involved water. This will really help with the next lesson. And you'll probably need to prompt them to note specific locations for where the light changes. Something that I found really helpful before we start modeling is talking about what happens when you place a pencil in a beaker of water. You see that the pencil looks like it's broken, it's shifted over, and we can talk about what's happening to the light at different spots, such as before it hits the water, after it hits the water, things like that. In this lesson, we refer to refraction as changing direction and not as bending, so that students don't think that the light is curving. We want to avoid that misconception, and we want to note that it changes direction and still continues in a straight line, so it's not curving, which is what bending can often mean when children think about that word. Well, where do we go from here? We know that we've figured out a lot about light and its interactions with matter, and that makes us wonder, can we use any of this information to help us explain our related phenomena and why that moon turns red during a lunar eclipse? Some material management tips and tricks for conducting the Rainbow Lab. If your paper copy, like your copy paper boxes, aren't big enough to be able to have the light and the object in there together, something that I found really useful is trifolds, because then that allows you to block the space, and it's very tall. So depending on where the light reflects to or refracts off of the objects, it kind of covers a lot of space. Depending on your flashlights, you may need to focus the light more in order to get a really good refraction and see a rainbow. So I have found that if you put foil over and kind of cut a slit, it really narrows the beam, and then that refraction is more noticeable. So definitely test out your supplies beforehand so you can kind of anticipate any certain like student problems they may have in terms of not seeing either the rainbow or the dimming of the light when it refracts. And then have a plan or time set in so that those lab groups can reset or clean up any sloshed water before the next lab group comes. Poster management. Not a whole lot of posters needed for this lesson. You will be referring back to that patterns and phenomenon in the sky poster you created previously. That is it for lesson 11. I hope your students really enjoy the Rainbow Lab and recombining the different colors of light to get white. I know that that is something that really surprises students every single year. And I look forward to seeing you in lesson 12.